So continuing with our discussion, so the next type of transcendental functions is your inverse trigonometric functions. Now, if you observe the formula, so I think if you observe the different formulas, so these are just the opposites of your derivatives. So for example, if you're given this particular answer, so kaning mga right side na equations, kaning arcsine, arctangent, and then arcsecant. So I believe that the given integrals are your derivatives, diba? So they are just the opposite of the other. So it's easy to understand because once you come up across with these types of equations, so in this format, so what you need to do is just to understand the format and then use the formula right away. So of course there are some procedures that we need to use U sub or the sub technique for us to be able to get to the simplified version of the equation. So most likely we'll be following the format, these formats. So again, we'll be doing a little bit of sub technique here. So we have to declare A, we have to declare U in our variables. So we only have three inverse trig functions. So arcsine, arctangent, and arcsecant. So question is, what if it doesn't follow the format being presented? So for example, it's not du over square root of a squared minus u squared, so on and so forth. So of course, that will be on the advanced trigonometric, I mean advanced integration techniques. So that I will discuss this coming March 2. Okay, so let's appreciate the formulas by solving some examples. So let's start with the first. So looking at your equations, so again, if you write the different formats of your formulas, so that's du all over square root of a squared minus u squared. So again, this corresponds to arcsine u over a plus c. And then you have du all over a squared plus u squared. And this corresponds to 1 over a arctangent u over a plus c. And then lastly is your du all over u square root of u squared minus a squared. And this one is 1 over a arc secant u over a plus c. Okay, so again, I forgot to mention that your a squared are your constants, and of course your u functions is a function of x. So again, looking at the three formats, so looking at the example, so it's more likely the arcsine format, ba? Okay. So what we'll be doing here is again we'll be declaring your different variables. So again we'll be doing some um, substitution process. So for example, your 9 is your a squared, then minus 16x squared is your u squared. So of course your dx is not sure if that's the exact value is I mean we're not sure if your dx is equivalent to du because again your du might be du over 2, negative du, or so on and so forth. Okay, so let's declare first your constant. So a squared is equal to 9. And then your u squared is equal to 16x squared. Okay, So getting the square root of both sides, so we have a is equal to 3. And then the other one is u is equal to 4x. So again, the purpose of um, getting the square root of a squared and u squared is because of your answer for your inverse trig functions, because you have u over a. Okay, so we now replaced your 9 with a squared and your 16x squared with u squared. So more likely the same as the formula. So what's left for us to do is to determine your du. So since you have u, so we can now derive this one. So du is equal to 4 dx. So as I mentioned earlier, so dx is not exactly equal to du, because du might be du over 4 or negative du. So in this case, your du is du all over 4 is equal to dx. Okay, so next is we replace this one. So again, a squared, u squared, and this one is du all over 4. So by replacing the equation is you have du all over 4 all over square root of a squared minus u squared. So factoring out the constant, that's 1/4. So you have du all over square root of a squared minus u squared. So looking at the equation, so that's equivalent to the given formula in the previous slide. So automatically our answer is 1/4, because we still need to multiply 1/4 to the integral of this solution. So that's arc sine u all over a plus c. So again, bring back the value of your u parameter. So you have 4x all over 3 plus c. So this is your final answer. So again, we cannot simplify this by canceling out 4, because your 4x over 3 is the angle of the arc sine function or the inverse sine function, and 1/4 here on the left side is the coefficient of the arc sine function. So if 1/4 is the angle of the arc sine, so it's correct to simplify by canceling out 4, but since this one is coefficient against the angle, so again we cannot incorporate that one, because dili siya pwede ma-mix, di ba? Unlike any other algebraic process or operation. Okay, so I think that's what you need to do. So all you have to do is to replace every term in the equation as your a squared and u squared, and determine du for the inverse trigonometric functions. So tip here is you always get your du from the u squared process. So u squared first, and then get the u. The next is get du. So that's the process. Because later on, once we reach the arcsecond uh, na problem, so you might be confused if we declare u is equal to something first. Then that's what we derive. So it might be faulty when we reach the end of the answer. So questions for this example? Okay, so wala ra. Okay, so let's proceed to the next example. So next is we have um, the integral of dx all over 25 plus 9x squared. So again, looking at your equation, This looks like the arctangent na formula. Okay, so that's du all over a squared plus u squared. Okay, so again, the answer for this one is 1 all over a arctangent u over a plus c. Okay, so again, declaring the variables, so we have a squared first. So a squared is the constant, that's 25. Then next is our u squared, that's 9x squared. So again, this one is a squared, this one is u squared. Okay, so what's left to do is to determine the du, which is this what needs to be replaced is your dx. Okay, for us to be able to get the du. So again, we get our du from u squared. So we get the square root of both sides first. So a is equal to 5, then u is equal to 3x. So from here is we determine the derivative after getting the square root of u squared. So du is equal to 3 dx. Okay, so isolating dx, so we have du over 3 is equal to dx. So as you can see, we have now replaced every term in your equation. So there's nothing left to be substituted in the equation. So by replacing, so we have du all over 3 all over 5 plus, oops, so that's a squared a squared plus u squared. Okay, so factoring out the constant, so our equation simplifies to 1/3 integral of du all over a squared plus u squared. So the answer is 1/3. So again, don't forget to multiply 1/3 to the integral of the equation. So that's 1/3 times 1 over a arctangent u over a plus c. So again, bring back the values of your u and a. So that's 1/5 arctangent 3x all over 5 plus c. So the final answer is 1 over 15 arctangent 3x all over 5 plus c. Okay, so questions or concerns with this example? Okay, so voila. So let's proceed with the next one. Okay, so if you observe the equation, so again, this is the format of, so it looks like it looks like the kaning arc secant na equation. So that's u square root of u squared minus a squared. So again, the answer for this one is 1 over a arc secant u over a plus c. Okay, so if you observe the equation, so notice that your u squared, that's 2x squared, and your a squared are not perfect squares. So of course, there's no rule that your u squared and a squared should be a perfect square. So of course, if the given example is in the format that is given in the formula, so even though that the terms or the parameters being presented are not a perfect square, so you still need to continue with the process. So regardless of your u squared or a squared are not a perfect square. So for example, in this example, so you have 2x squared, so 2 is not a perfect square, then 10 is not a perfect square. But again, we still need to follow with our process. Okay, so again, we declare the squared terms first. So u squared is equal to 2x squared. Then our a squared is equal to 10. Okay. Okay, so again, we don't include the negative sign because it's included in the format already. But so looking at the equation, so the negative sign is already part of the equation. So that's why we only declare 10 as your a squared without the negative sign. Okay, so looking at your equation, so this one becomes u squared, this one becomes a squared. Okay, so getting the square root of the terms. Oops. Okay, so u is equal to square root of 2x, right? Then the other term is a is equal to square root of 10. Okay, so getting the derivative of your u parameter is du is equivalent to square root of 2 dx. Okay, then isolating your square root of 2 to determine dx. So du all over square root of 2 is equal to dx. So this one is your dx. So notice in the term is what's left for us to substitute is the x variable only. Kaning x variable dire. So where do we get x in our equation? So again, ang atong du is coming from your u squared. So to get our x, so in the process of determining the du, so notice that in the second step, once we squared our term here, get the square root. So notice that we can use or we can utilize this equation by isolating x. Okay, so u all over square root of 2 is equal to x. So this one is going to this term here. Okay, so meaning every term in the equation is determined from the u squared parameter. Okay, so why do we need to determine from u squared first? So again, if we try to solve on the right side, so let's try another color. So let's say we declare first the x parameter and we determine u squared later. So let's say this one, so following the format, so your u is x, right? So u is equal to x. Diba? Pwede na siya, diba? Then squaring the terms, so u squared is equal to x squared. So looking at your equation, so medyo di kita maka-replace, di ba? Di kita makailis kay this one is 2x squared, this one is only x squared. So even though we want to replicate the term inside the radical expression, so by multiplying 2, so you have 2u squared is equal to 2x squared. So we have achieved 2x squared, but notice that in the format of your inverse trig function, it's only u squared, not 2u squared. Diba? So magkaproblema tayo if musugod ta sa u una. So that's why we start at u squared and then determine the rest of the parameters by dissecting u squared to u, then getting the du. So all is coming from the u squared. Okay, so muna siya ang purpose why we start with u squared. Because if we start with the lowest degree, so it might end up in a difficult scenario. For example, this one, diba? So 2u squared, and this one is not following the format anymore. So murag muna siya ang problem. Okay? So continuing with the solution. So since we have done determining every parameter, so dx is du all over square root of 2. Your x term here is, so let's try to encircle. Your x term here is u all over square root of 2. Then square root of u squared minus a squared. So notice that we can cancel out square root of 2. So what remains in your equation is du all over u square root of u squared minus a squared. So this one is exactly the same as the given format for your inverse trigonometric integrals. So the answer is 1 all over a arc secant u over a plus c. So bringing back the value of, so that's 1 over square root of 10 arc secant square root of 2x all over square root of 10 plus c. So if this one is your answer, so it might be that I won't give you full credit because this one is not yet simplified because there's a radical expression in the denominator. So if you recall your algebra, so we tend to eliminate the radical expression in the denominator because malagbati siya tanawon, di ba? So I don't know the real purpose why we need to eliminate the radical expression. So basin siguro batig naong, di ba? Batig tanawon na radical expression. So again, by rationalizing, so if you don't know how to rationalize, so the term is rationalization. So just search this one online. So if you don't know how to rationalize, so the final answer is square root of 10 over 10 arc secant. So this one is square root of 20 x all over 10 plus c. So simplifying even further is we have square root of 10 over 10 arc secant. So since we don't have any more space, so let me make this in a shortcut manner. So square root of 5 all over 5 x plus c. So ngano nahimo siyang square root of 5 over 5, square root of 5 over 5 na lang siya. So square root of 20 is, if we try to break this one, is you have 4 times 5. So since 4 is a perfect square, so this becomes 2 square root of 5. Then since over 10 man siya, so cancel out. So that's why it's square root of 5 all over 5. Okay? So questions for this example? So I think there's no question. Okay, so I hope you understood the inverse trig function. So again, um, the important process here is for you to replace or to follow the format given in the inverse trig formulas. So declare u squared first, declare a squared first, and then determining the other parameters such as your u and your du. So that will be coming from the u squared parameter. So of course the finished product of your sub technique here. So it's just sub technique because since you need to sub also a, so it's not totally u sub, di ba? Because you have the a parameter. So pili po siya sub technique. All right, so I think that's all for this topic.